Introduction. On your birthday, one of your friends gives a box of chocolates. Another friend gives another box of chocolates as birthday gift. So now how many chocolates will you have? Without opening the box, we cannot find the total number of chocolates. In these cases, we use variables for unknown number of chocolates. By solving the equation formed, we can find the number of chocolates, which is the unknown. Objectives. At the end of this lesson, you'll be able to solve equations, apply for problems involving lengths and distances. Equations. A mathematical statement that has two expressions separated by an equal sign is called an equation. The expression on the left side of the equal sign has the same value as the expression on the right side. A few examples of equation. One or both of the expressions may contain variables. When an equation contains only one variable, it is said to be an equation in one variable. That is, 7x plus 4 is equal to 5. 5x squared plus x is equal to 8. If an equation contains only two variables, it is an equation in two variables. That is, x plus y is equal to 8. X squared plus 2y squared minus 5x is equal to 0. Linear equation. If the highest power of the variables x is an equation is 1, it is said to be a linear equation. That is, x plus 4 is equal to 5, 2x plus y is equal to 8. In other words, linear equations involve only linear polynomials. Sides of an equation. Expression on the left-hand side is known as LHS and on the right-hand side is known as RHS of the equation. LHS and RHS are the sides of an equation. Solution of equations. The value of a variable which makes the equation true is called solution of the equation. Consider the equation. Therefore, 9 is the solution of x plus 3, which is equal to 12, since it makes the equation true. Note that other values are not solution of x plus 3 as 12, since they do not satisfy the equation. Solving equations. Any operation done on one side of an equation must be done on the other side also for the equation to remain true. This is the basic rule used to solve equations. Transpose method. We have also seen that the transpose method is the most convenient to solve equations. To apply this method, the following rules are used. 1. A term in an equation that can be transferred or transposed from one side of the equation to the other by changing its sign. For example, if x minus 12 is equal to 5, then x is equal to 5 plus 12. If x plus 1 is equal to minus 2x, then x plus 2x is equal to minus 1. 2. A number that divides a variable or a constant on one side when transposed multiplies on the other side and vice versa. For example, x upon 5, which is equal to 10, becomes x as 10 into 5, which is 50. 5x is equal to 10 becomes x is equal to 10 upon 5, which equals 2. Using these rules, the variables are transposed to the left-hand side and the constant terms to the right-hand side. Simple equations. Example. Solve 3a minus 5 is equal to 16. Solution. 3a minus 5 is equal to 16. 3a is equal to 16 plus 5, transpose minus 5 to RHS. 3a is equal to 21. Simplify RHS. a is equal to 21 upon 3. Transpose 3 to RHS. a is equal to 7. Simplify RHS. Equations with variable on both sides. Example. Solve x minus 3 is equal to 5 plus 5x. Solution. X minus 3 is equal to 5 plus 5x. X minus 5x minus 3 is equal to 5. Transpose 5x to LHS. Minus 4x minus 3 is equal to 5. Simplify LHS. Minus 4x is equal to 5 plus 3. Transpose minus 3 to RHS. Minus 4x is equal to 8. Simplify RHS. X is equal to 8 upon minus 4. Transpose minus 4 to RHS. X is equal to minus 2. Simplify RHS. Check LHS is equal to minus 2 minus 3 is equal to minus 5. RHS is equal to 5 minus 10 is equal to minus 5, which is equal to LHS. Complex equations. Example 1. A upon 3 plus 1 upon 4 is equal to A upon 2 minus 2 upon 5. Solution. A upon 3 plus 1 upon 4 is equal to A upon 2 minus 2 upon 5. 4a plus 3 upon 12 is equal to 5a minus 4 upon 10. Simplify both RHS and LHS. 4a plus 3 upon 12, 5a minus 4 upon 10. Use cross multiplication. 10 into 4a plus 3 is equal to 12 into 5a minus 4. 40a plus 30 is equal to 60a minus 48. Simplify both RHS and LHS. 40a minus 60a is equal to minus 48 minus 30. Transpose 60a to LHS and 30 to RHS. Minus 20a is equal to minus 78. Simplify RHS and LHS. A is equal to minus 78 upon minus 20. Transpose minus 20 to RHS. A is equal to 39 upon 10. Reduce the answer into its lowest term. Check. LHS is equal to 39 upon 10 into 1 upon 3 plus 1 upon 4 is equal to 39 upon 30 plus 1 upon 4 is equal to 13 upon 10 plus 1 upon 4 is equal to 62 upon 40 is equal to 31 upon 20. RHS is equal to 39 upon 10 into 1 upon 2 minus 2 upon 5 is equal to 39 upon 20 minus 2 upon 5 is equal to 39 upon 20 minus 8 upon 20 is equal to 31 upon 20, which shows RHS is equal to LHS. Word problems. Example 1. One number is half the other. Sum of two numbers is equal to 6. Find the numbers. Solution. Let one number be x. The other number is equal to x upon 2. Sum of two numbers is equal to 6. Hence, x plus x upon 2 is equal to 6. That is, 3x upon 2 is equal to 6, or x is equal to 12 upon 3, which is equal to 4. The numbers are 4 and 2. Check. The sum of the two numbers is equal to 6. Hence, the answer is correct. Example 2. The numerator of a fraction is 3 less than its denominator. If the numerator is increased by 1 and the denominator is increased by 3, the fraction becomes equal to 1 upon 2. Find the original fraction. Solution. Let the denominator of the original fraction be x. If the numerator is 3 less than the denominator, then numerator is equal to x minus 3. Original fraction is equal to x minus 3 upon x. The denominator of the new fraction is equal to x plus 3. The numerator of the new fraction is equal to x minus 3 plus 1, which equals x minus 2. The new fraction is equal to x minus 2 upon x plus 3. The new fraction becomes 1 upon 2. Hence, x minus 2 upon x plus 3 is equal to 1 upon 2. X minus 2 upon x plus 3 is equal to 1 upon 2. 2 into x minus 2 is equal to 1 into x plus 3. Apply cross multiplication. 2x minus 4 is equal to x plus 3. Simplify LHS and RHS. 2x minus x is equal to 3 plus 4. Transpose x to LHS and minus 4 to RHS. X is equal to 7. Simplify LHS and RHS. Original fraction is equal to x minus 3 upon x is equal to 4 upon 7. Check. Original numerator plus 1, original denominator plus 3, which is equal to 4 plus 1 upon 7 plus 3 is equal to 5 upon 10, which equals 1 upon 2, which is correct. Example 3. The sum of two numbers is 35. Their difference is 13. Find the number's solution. Let one number be x, then the other number is 35 minus x. The difference of the numbers is 13. 35 minus x is equal to 13. 35 minus 2x is equal to 13. Simplify LHS. Minus 2x is equal to 13 minus 35. Transpose 35 to RHS. Minus 2x is equal to minus 22. Simplify RHS. X is equal to minus 22 upon minus 2. Transpose minus 2 to RHS. X is equal to 11. The two numbers are 11 and 24. Check. Sum of numbers is equal to 11 plus 24, which equals 35. Difference of numbers is equal to 24 minus 11 is equal to 13. Hence, the answer is correct. Example. Two numbers are in the ratio of 3:4. Sum of two numbers is equal to 56. Find the number's solution. Let the numbers be 3x and 4x. Their sum is equal to 56. 7x is equal to 56. X is equal to 8. The numbers are 3 into 8 is equal to 24 and 4 into 8 is equal to 32. Age problems. Example 1. Anil is 9 years older than Ajit. In 10 years, Anil will be twice as old as Ajit was 10 years ago. Find their present ages. Solution. Let Ajit's present age be x. Look at the table given here. The problem says, 10 years hence, Anil will be twice as old as Ajit was 10 years ago. Anil's age 10 years hence is equal to x plus 19. Equation 1, Ajit's age 10 years ago is equal to x minus 10. Equation 2, therefore 1 is equal to 2 into 2. X plus 19 is equal to 2 into x minus 10. X minus 2x is equal to minus 20 minus 19, or minus x is equal to minus 39. Therefore, x is equal to 39. Their present ages are, Anil is 48 years, Ajit is 39 years. Check. 10 years hence Anil will be 58 years. Ajit was 29 years old 10 years ago. Checking. 58 is equal to 2 into 29. Hence LHS is equal to RHS. Example. The distance between two places A and B is 240 kilometers. A motorcyclist starts from A and a pedestrian starts from B at the same time. The speed of the motorcyclist is 15 times that of a pedestrian. 3 hours after they start, they meet at a point M. How far is this point from A and B? Solution. Total distance is 240 kilometers. Let the speed of the pedestrian be x kilometer per hour. Total distance is equal to 240 kilometers. Distance covered by pedestrian plus distance covered by motorcyclist is equal to 240 kilometers. 45x plus 3x is equal to 240. 48x is equal to 240. X is equal to 5. They will meet at the point M, which is 15 km from B and 225 km from A. Summary. Let us summarize what we have learned. A statement of equality between two algebraic expressions involving one or more variables is called an equation. If the highest power of the variables in an equation is 1, it is said to be a linear equation. Any operation done on one side of an equation must be done on the other side also for the equation to remain true. Transpose method. A term in an equation can be transposed from one side of an equation to the other side by changing its sign. A number that divides a variable or a constant on one side when transposed multiplies on the other side and vice versa. While solving word problem, do the following steps. 1. Identify the unknowns. 2. List out the given data. 3. Form the equation using given relation. 4.